This video is discussing pressure of a gas. Okay, so pressure is the amount of force exerted over a given area. So the more force over the same amount of area, the more pressure it has. What we're going to be talking about in this class is our pressure events. And pressure events are the collisions between particles and the container walls creating the pressure force. Okay? Pressure events are only significant for gases. They are not significant for liquids or solids. So what we're going to do is we're going to draw a particle picture. Okay, so we're talking about a gas. So here's my gas. And what it's going to do is it has a pressure event. Remember, pressure events are caused by a force being exerted on a wall. So what I want you to do is always draw the particle, and then with the whooshy, draw a tail coming off and with it bouncing off. So what this is saying is that the particle went this direction and bounced off, and right here is the pressure event. What I really want to make sure that you do is when you do the pressure events, you can either choose A, to circle them on the wall like this, or when you're just doing a pressure event, just really make sure that it bounces off of the wall. And I can see that that like V is touching it. Atmospheric pressure is the pressure that's exerted by the gases of the atmosphere, okay? Which means that the air particles. And atmospheric pressure changes depending on the weather and the elevation. So what we're going to do is we're going to draw a particle picture of the air particles that are above sea level, and we're going to draw the pictures below sea level, okay? So above sea level, think of if you're climbing a mountain. What happens to the amount of air? Well, your amount of air goes down, so therefore the pressure goes down, okay? So we're going to draw particles, and we're going to draw the air pressure. So we're going to draw less particles for above sea level, and the reason why is because we have less pressure and we have less particles, and so our pressure events should be less. Now, not every single particle is bouncing off a wall at a given time. So I have, here's a pressure event right here, and then I've got no pressure event with this guy. Okay, and that would be totally normal. So this guy above sea level, I have one pressure event. Why? Because I only had 3 particles. But notice everything has a whooshy because everything is moving. Now let's try below sea level. Okay, so what happens below sea level is you actually have more gas particles. So instead of having 3, I'm going to draw 5. Now they're not all going to be, once again, having pressure events at the exact same moment. What they are going to be doing is they're going to be moving, okay? And the pressure events, because we have more particles, will be having more pressure events. So therefore, it's going to have more pressure. So we're going to bound, I just extend it and make that a pressure event. And I'm going to choose to extend this one and make that a pressure event. So this one had 2 pressure events. It doesn't matter how many pressure events you really have. It's just what you need to do is show that it has more or less pressure. How does a balloon change its pressure? Well, a balloon always makes sure that its pressure is equal to the surrounding pressure. So what it does is it will always have the same amount of particles, but it'll expand and contract to make sure that it either can have more pressure events or less pressure events. So in a low atmospheric pressure, okay, I'm going to draw, let's say, 4 particles. If it's low atmospheric pressure, that means it will have lower pressure events. It will also have lower pressure events. So it's going to expand, and what that's going to do is it's going to allow these particles to spread out and not be as likely to run into the container. So there will be some pressure. You have to have at least a pressure event occurring because there's always pressure if you have different particles. If you have any particles, there's got to be some sort of force that it's exerting on something. So you always have to draw at least one pressure event, and I'm always going to be comparing your pressure versus another pressure. It's going to be a comparison type of thing. A high pressure event or a high atmospheric pressure means that I will have more pressure events. Once again, the balloon will contract under high pressure. It will still have for those 4 particles, but the problem is that the space in between it is a lot smaller. So by default, it's going to have more pressure events. Now, once again, they're not all going to be having pressure events at the same time, but they will have more. So this one on the left had 1 pressure event, and the one on the right had 2 pressure events. You could make it 3, I just wouldn't make it 4. But what I'm doing is I want to compare them from the low atmospheric pressure to high atmospheric pressure. With pressure, there are 3 units that you are going to absolutely need to know. And they're all they're not interchangeable. They all can be converted from one into the other. Okay, very important to know these. So kilopascals is the first one. This is actually the scientific unit that we use for pressure. Its symbol is K with a capital P and then a lowercase a. Atmospheres is typically what you use in chemistry. Kilopascals is usually used in physics. If you're discussing pressure, atmospheres is usually discussed in chemistry. And then millimeters of mercury is actually meteorology or weather. Okay, but they all can be converted from one to the other. So atmosphere is the pressure at 0 degrees Celsius at sea level. So basically at the ocean when it's 0 degrees, so it's freezing, you would have an equivalent of 1 ATM or 1 atmosphere. That's how they figured it out. Millimeters of mercury symbol is mmHg, and that stands for the amount of liquid mercury that can be pushed in a tall column by an atmospheric pressure. And so because meteorologists care about the atmosphere, that's why they tend to use millimeters of mercury. It's literally a tube that where the mercury goes up or down depending on the atmospheric pressure. Okay, so if there's more atmospheric pressure, it goes up more. If there's less, it goes down. All right, so these are the different conversions that you're going to have to be able to use. You obviously do not need to have them memorized, but you will have to be able to convert between them. So 1 atmosphere is equivalent to 760 millimeters of mercury, which is equal to 101.3 kPa. So let's try to do some conversions. There's 2 different ways that you could do them. One, you could do proportions, which I'll show you, and then you could also use the dimensional analysis technique, which I'll also show you. So the first one I'll do is proportions. So we're trying to convert 4.5 atmospheres into millimeters of mercury. So I know my 4.5 ATM, and I'm trying to go to millimeters of mercury. That is going to be equivalent to these guys up here as far as proportions go. So the top one, because this is atmospheres up here, atmospheres needs to be over here. And because millimeters of mercury is here, it needs to be on the denominator on the other side. So I'm going to write 760 and 1. Now I just need a cross multiply, and I get 4.5 times 760, and then I'm going to divide by 1, and so I get 3,420 ATMs. I'm sorry, millimeters of mercury. With sig figs, because 4.5 has 2 sig figs, rounding this to 2 sig figs, it'd be 3,400 millimeters of mercury. Okay, so that is using proportions. If we wanted to, if you'd like the conversions method or the dimensional analysis method, then we'll try it this one now. So we've got 420 kPa. Okay, so I'm going to set up my field goal post, my T's, whatever. kPa is up here, so it has to go on the bottom on the next one. And I do know a conversion between kPa's directly and atmospheres, so I'm going to go straight to it. And so I've got 1 atmosphere, and then it's 101.3 kPa's. So all I'm going to do is I'm going to snake through. So I'm going to do 420 times 1 divided by 101.3, and then press equals. And so 420 times 1 divided by 101.3 equals 4.146. And then that would be ATM. Now I just have to round to the correct number of sig figs. I'm always going to base it off of the number that's given to me in the problem. So this would have 2 sig figs. So I'm going to round my answer to 2 sig figs. So this would be 1, 2. That number is going to stay the same. So it is 4.1. The 4, 6 will drop off because it is they are located after the decimal. So you end up with 4.1 ATM. All right, let's see the next one. And so now we're talking about STP. This is just a basic definition that you absolutely have to have memorized. STP stands for standard, temperature, and pressure. That's where we get the STP. By me telling you STP, I am telling you the conditions of the environment. I am telling you its temperature and its pressure. We just defined standard as these. What standard temperature is 273 Kelvin, which is equal to 0 degrees Celsius. So I could either write 273 Kelvin or 0 degrees Celsius. Both would be considered standard temperature. Standard pressure would be 1 atmosphere or 101.3 kPa, or 760 millimeters of mercury. We tend to use ATM just because we're chemists, but you can use any of these. So if I ask for what is standard pressure, you would say 1 atmosphere, or you could say 101.3 kPa, or you could say 760 millimeters of mercury, and you'd be right every single time. If I asked you for standard temperature, it is either 273 Kelvin or 0 degrees Celsius. All right, hopefully you have a basic understanding of how to draw pressure events, okay, how to convert between different pressure units, and the definition of STP and its conditions.